Uh, Good evening, folks. So we are here to discuss a model which is created by me, an e-commerce intent prediction agent. So this project is created by like two people, me and my friend Sahil. So this is like the GitHub repo which I will share you in the link. Now I am going to show how how we have implemented this project. What are the steps? What are the feature engineering things which we have did to make this project successful? And first of all, what is the business statement and all such things? So let's start. So whenever we land in a e-commerce website, then we make some actions to the website. Now there is a problem. So what the problem is when companies like Amazon wants to show recommendations, the personal recommendation, then what they need to do, they need to have your ID. So you have to sign in first. Where is that? You have to sign in first. Then there is like a history being recorded for you. What he has done in that day, what he usually takes, what he usually search for, what are the things which he carts for. When he just abandon, like what is the time? Like if he is watching like very costly things, then he used to abandon these things. On the basis of the history of these things, the recommendation systems work. Like you tend to believe how Amazon and all such things make shows you the similar thing which you require. So all these things are implemented through tracking your behavioral things. So this is when there is a user ID associated. Like when you have when you have a dedicated user ID, for example, Saksham at the rate 123 123, then your activities get recorded and you get the personalized recommendations. But now there are many people in the websites who tend to visiting for the very first time, like first time visit. In the first time visit, what they don't have, they usually don't sign in. Like they don't sign in, and they don't sign in, so there is not a track of the history of such users. Now now still now the website all now the e-commerce companies also require to give them the personalized recommendations to increase their sales. But since they are not being a there is no association of user ID, so their activities can't be recorded. So what is the business problem which we have identified? How can we have recommendation for how can we have recommendation in user session? So like we will only judge the user session. For example, if we go to a website and without sign in, we just do some actions like I see iPhone, then I go for a Samsung. So on the basis of such activities, like what kind of activities is he doing, how much is he changing his price and all such things, how much he stays for how much time he stays in the website, what is the idle time. So all such things, on the analysis of this, we would judge whether someone would buy things or not buy things. So we would judge whether you buy or not, whether you buy or not. So what are or not. So what our model would do? So the model so this is like our ML model. Now there are some features like and there is user, and there is users activity, no user ID, only user session, the present user session. On the basis of it, it would generate a probability like 0.76% of buying the things. So give we would give different we would give different discounts like if you purchase in 10 minutes, you would get 10% discount on this on that. So we will do these things. So at the end, we are going to implement the recommendation systems for user sessions. So recommendation system for user. for user session, which is being a very tough task nowadays, because it only includes the activities for seconds. You came to the website and you did some actions. On the basis of actions, we are going to predict whether you are going to buy it or not. So this is a problem statement which is usually not being picked by everyone, and it has been like chosen by us, and also implemented a very cognitive model to judge whether someone would buy or not. So first of all, I would let you know how is the data. Before it, I want you to go to the Kaggle website, which I have used for the data set. So this is the Kaggle website. This is the Kaggle data set which I have used. Now the data set was being very huge, like 14 GB. I don't have enough space in my RAM to include such a big file. So what I did is, so I like I what I implemented is, uh, first of all, let me tell you how the data look like, how the rows look like. So what different things are there in that data, in that tables. So there is an event time, like when an event is being recorded. Then there is an event type. There are three types of event which is being recorded in the tables. The very first is view event, where only the view happens, like what he said, what he like saw in at that time. So at 12 p.m. it made a view with product ID. So every product got a unique product ID, as well as the category ID, Now there is a category code. So he had seen, so the user had seen a notebook, like computer's notebook. There's a computer notebook with the brand of HP, and the price of it is $514, 514.56 dollars. So there are two things. Uh, we have got the user session, like user session, and we have got a user ID. Now remember, now I remember, a user ID could have multiple user session. Like I came to the website at night, user session 1, user session 2, user session 2, user session 2. It's not like it could be like at 2 p.m. I came, and then just I refreshed then just I surf for the website and then get leave from the website. So this is what a user ID could have multiple user sessions. Now what we have did is, mm, so there are two things. Category ID, this is our numerical value, which is system generated, and product ID is also unique for every product, which is like mapped to the product. For example, the product here is notebook product. Now a category, now the very important things to identify which product is this. Then we have got this things, like the category code and the brand. So in that category code, we see that the user is under the electronic sections, and in that electronic sections, he is surfing for the videos thing, and in that video thing, there is a TV. So TV is the commodity. TV is something which is user looking for. Now, which brand TV? So it's a Samsung brand TV. So the brand is Samsung. So this is how the user's history is being user history is being traced down. So for every user session, so for every so their unique user session, like this user session is being unique in this session, and we will get every rows which are mapping to that user session. Like if it could be there, then after it could be like another place. So all the time the user has served to the website, all the events which he has done, like easy viewed the website, easy made a view over it, or did he or there is like a cart session, he put something into the cart, or there is kind of a purchase thing which he has did. So all the things are being recorded. Like for this, in the further rows, there are also other rows which is tracking all the history which is made by that user. Now we talking about this, how we maintained to incorporate such big data set into our data set. So what we did is, the data set was roughly of 13 GB. Now we at roughly of 13 GB, we just make it as a 10% and we did 1.3 GB. So what we did is, so so we first uploaded the things in chunking. So we do know chunking, what happens in chunking. In besides chunking, in the underlying code of chunking, there is a generator working over here, which works on the yield principle. So one chunk come to the memory, one chunk come to the memory, then leave the memory, then another chunk come to the memory, then leave the memory. So through it, the space, so through it is referred to as lazy loading, which makes the which lets to utilize the RAM in a more efficient manner. So what we do is, we take a chunk with certain rows. Now we drop any, we drop usually the sessions where user session is not existing, because if user session is not existing, then it is not of any kind of use to us. Now we for every user session, we make an apply thing. Now we filter every chunk. What is chunk? So chunk is a set of rows we have got. So we got set of rows. Now in that set of rows, what we tend to do, we select only certain user session, for example, this user session and this user session, and discard other sessions. So, and we also ensure to keep a session intact. For example, if I have a user session like 1, 2, 3, 4, so I kept all the rows which are resembling the user session 1, 2, 3, 4, to so that our data is complete. It is not like that data is the data contains some rows for some session, then no other rows for same session, because it will make our model corrupt if we don't have the if we don't have the complete rows resembling to a user session. Then there is modulus, and so there is kind of there, this is being an easy course. You can do go to Gemini for it. You will understand that how I have implemented, how I have managed to compress 13 GB into 1.3 GB dataset with also retaining all the rows, all the user sessions I want. So it's like a situation, if I've got 1000 user sessions, if I've got 1000 user sessions, that's just an example, then I included 10, then for making it the 10%, I just included 100 user sessions, not the complete user sessions. Okay. Still, even 100 user sessions is being good for like error analysis. So then there is some of the basic details which is being there. What is the event type, what is the event type, product ID, and all such thing in 64, then float 64, and all such object. It is an object. Even date time is an object, so we need to use speed development to date time to convert it to date time, and then do our operations related to the date time. Now what we did, how many different user sessions after doing the separation, like compressing the file, we can say for our convenience, like 1,37,822. Still these sessions are there, which can bring our analysis, and through which we can train our model. So how many duplicate sessions are there? So there were only a needle in an ocean. It's like a needle in a haystack. So 10,434, which is not a big number. So what we did is, we just dropped it, final df, only the 0.15% data is being missing. So we removed that data. Now df.met drop duplicates. Now we have got a final df, which is we have got a final df. Now we have got a final df which is free from duplicate things. Okay. So now what we are going to do is, now we are going to do analysis of how we have managed the null values. So we are going to see how null values are being managed. So when I run this code, I got to know that there are many null values in the category code. Now, what is the category code? Category code is something which is telling what the user surfing in. For example, some of the category codes such as if user is surfing around to buy a refrigerator, then it is getting like this: appliances. Then there is kind of kitchen, then there is chair. So user is being so this is the broad category. Then under it there is kitchens. Then under it this is the specific item for which user is searching. User searching for it. This is the specific item. Now after it, what we have now after it, even the brands are missing. Like there are some things which are unbranded. Now a question arises: why category code is missing? So why category code is missing? Why category code is missing? So usually what happens? That there are many local products. For example, there are many local products. If I say that there is a uh, what could I say? Like if usually there are uple that we refer to as cow dungs. There are uple in cow dung. Uple, if you have no in village there are uples, so still they are being sold, and still they are being sold in the e-commerce websites. Now there is no category code being filled for such kind of items. There are very random items. There are many shopkeepers who tend to provide items which have no which are very which are not branded things. For example, I can say like there is no category code for it. Or another example, if there is like papad being selling by a local user on the on e-commerce, then there is no description of these things as well. If diya is being sold in the e-commerce website, I'm just taking the cases that it could be a possibility. Like there are diya which we used to light up when there is like Diwali. So there is no category code for these things. No category code. So these are the so local shopkeepers when tend to sell the things on e-commerce websites, then they do not provide the category code associated with these things. So this could be the very first reason. Second thing, it is the duty of the employees of e-commerce to label these things, but sometimes tend to make mistakes like human error. They tend to have do the mistakes like human error. So these are or they haven't yet provided they haven't provided the category code yet provided category code yet. uh, so there are different situations when these things tends to happen. There are category code missing, and there are brands missing. Like corresponding to that, corresponding to the things where the brand is missing, where the category code is missing, then the brand is tend to be missing for such places, because for such items. Besides of it, other brands are also missing. So this is being like there is, if we see at the data, what we have found. If we see at the data, what we have found that there are 32% value in the category code and in the brand which are missing. Now this is being a huge number. We can't we need to tackle the situation by hook or by damn crook, otherwise the model would get disrupted by these missing values. So now first of all, what we have did, we tried to check what is the relationship of the missing values with the other missing values. So we try to find whether the category code or brand which we have are they missing completely at random, or missing at random, or missing not at random. So there are three types of missing values which is in the which are usually being classified. So there are different tests which is being done to evaluate whether missing completely at random or missing not at random. So first of all, we tend to see whether the density. So we tend to see whether there is a relationship between the densities of the two things or not. So what we have did is we have implemented. So what we did is we have implemented we have like we have a visual explanation of how missing values are being related. So we have a library referred to as the missing go libraries. Now in that missing go libraries, I have sampled 200 sessions, and I put these sessions into that for the analysis of the missing values. So we have got so the blank which is being appearing here is the missing values. Now when we did the analysis, when we performed the test over both the things, we have found that they are missing completely at random. Now this is an interesting thing which we have found, that they are completely at random. It means that the missingness of the category code, what we have found, the missingness of the category code or brand is not interrelated. Category code and brand is not interrelated. Is not interrelated. Is not interrelated. So how we have done these things using two tests which we refer to as the T test, which we like the test which we use as T test. So what we did is, first of all, we uh, first of all, what we did, we take a brand, we take brand with no missing values, with no missing values, and another with missing and another, like this is a brand, this is the column of brand with no missing values, like we separated it. And there is also a brand with missing values, corresponding to this we have got the category code. Corresponding to it we have the category code. Now what we can see is, since what we can't why we can't do anything here is, like we can't conduct tests here, because the value which are being used here are not continuous values. Usually the testing mechanism like t-test to evaluate whether it is missing completely at random, missing at random, missing not at random, is being done over continuous values. But since they are but since it is not it is not continuous things. These are associated with some of the products, so we can't do any kind of relationship in it. But for computing the category code and brand, we also implemented some of the other methods too. So what we saw, that product ID is being complete. Cat- Category ID is also being complete. Now these two things tend now product ID and category ID tend to map at unique category ID and brand. So what we tried to implemented, so I would like tell you how the code is working. So what we have done here is, I'm just having a piece to be cut and then doing the evaluation. So now what we have is, what we saw here is like the product ID is completely filled with, and the category ID is completely filled. So what we tried to did, we tried to map product ID with the category code. So what we did is we mapped product ID with the category code. And what our notion is, that if for example there is a product ID 2 for which the data is none. not a number, it is missing. But for the similar product, there is for the similar product, there the value is being existing. For example, the category code exists. For example, it could be it could be a smartphone. So what we thought, if we have got such relationship, then we can propagate that, we can replace that nan value with the smartphone. So we thought of this hypothesis too, to make this to do it. But what we have found is that there is no such kind of relationship. There is no such kind of relationship we got while doing the analysis. So uh, uh, so what we found is, for if there's a product ID 2 for which the values is being missing, then for all the two which are being appearing in the category, which are being appearing in the category code, it it is still missing. So the first hypothesis got wrong. We tried to implement it, but we didn't get the results. Similarly, we established for category ID and category code, but there is only one place where we have got a very slight success. That where what we- where we have tried to fill the brands with the product ID. So we did a mapping of product ID with the brand. So we did a mapping of product ID with the brand. So for example, there is one product, then there is none, but there is another product ID with as one, but it is given with some like brand. For example, could be said as Samsung. So what we did is we replaced nan with the Samsung, and that we have got a very slight success, not so much success. But still slight success is being a success, so we can't discard such success. So this is the code which you see here. What we did, we set index category ID, then we did a dictionary, then we implemented a dictionary, and then we try to map and all such stuff. It is being easy. You can you can understand the code by itself, so no worries at all. uh, so these are the things which we like which these are the uh, measures which we implemented to handle with the null values. Now since we didn't get any kind of measure to treat these null values, so I would tell you later what are the steps further we implemented to get rid of these null values. For the time being, we are going to move to the other section where I am going to show you how data cleaning is being done. So first of all, I will tell you how why we need to have data cleaning here. So first of all, we will implement why we need to clean the data. Why we need to clean the data? Need to clean the data. Now clean the data. First of all, besides of null value, there is null value. Besides of null value, besides of null values, what steps we need to implement it? We need to implement it here. So what we did is, so usually what happens? Usually what happens in an e-commerce website? There are different in an e-commerce. For example, if just leave everything. For example, if you are downloading a movie over the internet, and you suddenly click on a link which gets you to the e-commerce website. Now you got to that website through randomly, like you haven't meant to be there to show your presence. So the users which tend to come randomly through some random clicks, throw some random clicks over some other website which lead you to the e-commerce websites. Then such user sessions, because you have marked your presence in that website and it is being recorded. So these user sessions are referred to as bounce sessions. These are bounce sessions. These are not the actual sessions. And if we talk about if we talk, so this is where the very first thing we need to discard such sessions which are bounce sessions, and also which are bounce session. And other thing is, uh, it is a e-commerce is a very competitive field. Like different different websites are there in the market. So what they tend to do, so what they tend to do, if there is for example, there is Flipkart. For example, this is Flipkart website. For example, this is the Flipkart website, and this is the Amazon website. Now what happens? Now what tends? What happen here is, like, Amazon tend to release some of the bots to the Flipkart websites. These bots tend to do the unusual activities on the websites to usually reduce the revenue of the uh, competitive company, uh, the company which they are against of, we can say in such a way. So they tend to release bots. We also need to we also need to implement the conditions to remove these bots. We also need to remove these bots too. So in that we are doing these things. So first of all, we have extracted the data. Now what we are doing the transformation. We are doing the transformation to our data. Now we are doing the transformation to our data. So we are doing transformation to our data. So how we have implemented these thing, I want to go through that thing too. So what we have did here is, let me like fetch your session for you so that you could understand it better. For example, I'm going to be quick. Okay. Uh, Sorry for keeping you wait. Uh, okay, where I can find the piece of code? I want to be like clear of the things which I'm going to say. Okay. So let's suppose that I'm going to take a screenshot of this thing just to explain you how the things are working here. So this is just a table, and then there is no need of other things too. So this is being like a table looking like. So what we have did is, this is the so what we have did is, this is the final df. This is the table which we have got here is. Now what we did a group by. We did a group by over user session. So what I have did is, I uh, uh, so what I have did is, I make this session, and this session, like all the sessions which are being included over here. Now these are the four sessions. So what I'm saying, these are the four sessions. Now we are going to do analysis over single session. This would come as a group, for example. Okay, are we ready? So first of all, let me remove this stuff. Okay, okay. So where is okay? This is here. तो कोई चीज़ सही टाइम पे चल रहा है तो काम की क्या उस चीज़ का फिर सही टाइम पे कुछ नहीं चलता, जैसे कि सही टाइम पे मेरा लैपटॉप नहीं चलता. ठीक है. सो this is the group which is this is being formed, like this is a single group which is here. Now what we did is, we did a group by and we did an aggregate operation. So first of all, there is a start time. So this is an event time. So this is an event time here. This is an event time here. Now what we picked is, we picked the minimum time. Minimum time is the time where the sessions, when the session started. So we take this event time, and then we take the end time. Like end time is the very last time. So there would be after some after some clicks there would be an end session, and total events are being event count. So these are the event count. For example, this is the thing. So this is being the thing. So how the data would be look like? So there is a user session. So how it would will look like? There is a user session, and in that user session, what we would get? There's a user session. For example, ABC. Here I would get the start time. Start time is the time when the session started. For example, it started at 12 a.m. Then there is an end time. There is an end time when the session ended. For example, 12:06 a.m. So sessions lasted for 6 minutes. Then there are total events. Total events record like is there any like how what is the quantity of views, cart and purchase. For example, there are seven total sessions. In that total session, it could be something like user did six views and one cart. So it is being recorded here. And total second duration, then we did just end time minus for start time, then dt dot my total seconds. So at the end, what we got is duration. We just got a duration of that session. Like it lasted for 6 minutes, then it would be six times 60. It would be like 60 like 360 seconds. So now we implemented a condition which is referred to as bounce condition and views per minute condition to remove such kind of thing, to remove the data, to remove the bouncing users and the bots. So we are going to study it in deeply, like how we have implemented these things. Uh, so this is the bounce condition. So first of all, what we have implemented, the bounce condition is when the total events being recorded. If the total events being recorded as one, if there is only one event, like one view per user session, or the session duration is five less than 5 seconds, then surely it is a bounce condition. Surely it is going to be a bounce condition, as no user tend to click only the one time and then go out to the website. So this is not actual user session that is being useful for for a machine learning model. So we take it as a bounce condition. Now what also we have implemented views per minute, like how much a session how much there are views, how much there are views over a single minute. For example, if it came out to be like 70 views per minute, 70 views per minute or 30 views per minute. So we calculated these things, and then bot condition is views per minute and total events. Now what we have implemented here is, if you see the bot condition, then the is being views per minute is greater than 30. Now, what does that mean? Like if like suppose the views per minute, like suppose the views per minute is 40 views per 60 seconds. So could you genuinely believe that a person could do such things like for every 3 seconds he tends to have two views. So this is something which is being very fast. Like 3 seconds is a very less time in that you clicked two events, you clicked two things. So this is not regarded as a this is a bot condition. The speed, the pace of the user is being very fast, which is like out of the range to a normal person. Like a normal person does not tend to have links in tend to open links in such a fast manner. So we tend to remove these things from our data set. And also we have implemented there should be certain events being being associated with the session. So when the speed is being very high and there are minimum sessions, minimum events recorded, then this would be regarded as a bot condition. So now what we did is we removed all the user sessions, all the we kept only the valid sessions, which are like removing the bouncing users and the bots mm, from our data set, and then take the valid users. So these are the valid sessions. These are so we need to do our analysis only over the valid sessions, not on the unvalid things. Then what we did is we just like clean df only so then we just use is in valid conditions, nothing else. So this table, now the clean df table is such a table which only contains the value, which only contain the user session which are actually the user session, which are actually in the data. So we are going to do our data analysis, training our model on these data set, like on this filtering condition. So now we are done with it. Now we are going to do now we are going to see some of the distribution to understand how how is our like what is patterns being seen over that data set. So can I just take some rest?